Okay. Who can tell me what a CAN ID is now?
I think a CAN ID is something like it tells you what the specific like ID of each part of the robot is, like motors, stuff like that.
Yeah, it's the specific ID of each motor, basically. You can also set them for, it's motors. This is what Phoenix Tuner looks like. So in Phoenix Tuner, there's two things that you would do in there. You can set offsets for the motors because a lot of these motors have encoders either built in or attached to them. For Phoenix, most of them are built in. Do you guys know what an encoder is?
No.
So an encoder is what basically you can tell what the position of the motor is. And so it tracks like how many rotations has the motor gone, except it has its own unit that it uses. And that's how in the code we're able to see what position is the motor at. So if you want to make attachment like an arm, for example, if you want the arm to go up 90 degrees, you would use the encoder to read what like angle the arm is at. So you could set offsets to your encoder because let's say that you want your motor, like your motor starts at 20 degrees up, but you want that to be 0 in the code, then you would set an offset to your motor. And then the IDs you'd also set in here. So for example, this is one of our drive motors and you can see that the ID is 1. And for intake, we start at 20 because that's a different subsystem than the drivetrain. And you also have to have ones for, So far, is this making sense? I'm going to explain one more concept because I'm not sure if you guys have heard this before, and it's not really related to the motors, but it's important to know. But on our drivetrain, we have this thing called a pigeon. Has anyone heard of this before? Can you explain it? No? Okay. So the pigeon is something called a gyroscope. And a gyroscope is kind of like the encoders in a way that it can tell position, but the gyroscope can basically tell you what the orientation of the robot is. So when we want the robot to move automatically, we need to use the gyroscope in order to make sure that like we're at the right orientation, and it basically tells us what the position of the robot is on the field. So that's what the pigeon is, and that's why like when we put the pigeon on the robot, you need to make sure it's in the center of the robot. That way it's properly reading the position of the robot from the center. And not like, okay, this is the robot's position, but it's actually in the corner, and it thinks the corner is the center. Okay? Okay. Now I'm going to start getting into our code and how it's set up. So first, I'm going to start with the Talon motor. Just to give you an idea of what the structure of the motor will look like, and then I'll compare it to the Spark. So Talons, this is a recap. These ones use Phoenix, and then the Spark Max libraries, those use Rev. And so for the Talons, first thing you need to do when you're making a motor is you need to instantiate the motor. So that's what this line over here is. Do you guys know what that means? Basically, you're making an object that holds the motor. So I'm saying public because I want us to be able to access the motor in other places. Talon FX, which is the type of the object, which I want it to be a Talon FX motor. I want it to be a Phoenix motor is basically what that means. So it doesn't have to be a Talon FX for you to use that library. If you wanted to use another motor that uses Phoenix software, like a Kraken, then you also use that object. And then motor is the name of it. You can name it whatever you want. You can name it Bob. I wouldn't recommend that. Name it something that actually relates to the motor, so when people read your code, they know what the motor is. Okay, and then after that, you need to make a configuration object. So what this means is basically, when you have your motor, there's a bunch of settings that you can make for your motor in your code. And the way that you would apply these settings to your motor is with a configuration object. And so that's why we need to make that. And then you start by, you define your motor more in here. So here is where you actually define your motor object. And you'd say motor equals new, and then since this one is Phoenix, we said new Talon FX. And then in the parentheses, you put your CAN ID. So your CAN ID can be whatever you defined it as earlier. That way the code knows what motor to talk to. And then you also need to define your configuration object. So for motors that use Phoenix software, you would do config equals new Talon effects configuration. So now I'm going to get into some of like the specific things you would define with your configuration object. So the first one I'm going to talk about is like your mode, kind of. So there's two modes that your motor can be in. There's brake mode and there's coast mode. So with coast mode, what that means basically is, let's say your motor's moving, it's going at like 100 RPM, which is kind of slow depending on what it is, and then all of a sudden you want it to stop. Instead of stopping right away, the motor is going to slowly go down in speed, and then it'll stop. So it's not going to like immediately hit the brakes and stop. And what you would use that typically is if you want to make like a flywheel, you might use coast mode. Maybe for our intake motors, you would use coast mode. That's where that would be applicable. The second type is brake mode. We use brake mode, I'd say, a little more often, but brake mode is kind of what the name says, where once you want the motor to stop, it's going to stop immediately. And it's going to stay stuck, so you won't be able to move it. So some cases we use this in is if you have an arm on your robot, you would use brake mode because you don't want the arm to keep swinging. If you have an elevator on your robot, you'd use brake mode, that way it holds its position. Anything that's velocity control, you can use coast mode for. But if you're doing something that's position controlled, that you want it to stay in that position, you're probably going to use brake mode. Are there any questions on that? Okay, great. Now I'm going to talk about current limits. So you guys like have an idea of what current is?
Yes.
Current is kind of like how much power the motor is drawing. And if the current limit gets, like if the robot's current gets too high, bad things happen. If the motor current specifically gets too high, you might feel the motor starting to heat up, smoke, won't work as well. We had some issues with that during the season. And so that's why you need to add current limits. What a current limit is it basically limits how much current the motor can draw. So a good current limit, I mean, it's going to depend on what you're making, but like 40 is pretty standard if you really don't want the motor to go over 40. That's what we had in a lot of our motors during the season, and that's what a current limit is. Okay, and then this line is basically what applies to configs. This one is written specifically for Phoenix because this is a motor that uses Phoenix software. And you just get the configurator from the motor because the motor has some functions to configure, and then you put your config object into it. And then the last thing I'm going to talk about for a really basic motor control is duty cycle. So this is your function that would actually move the motor. What duty cycle is duty cycle, basically you're just telling it how much power you want to give it. And so that ranges from -1 to 1. -1, it would go backwards. 1, it would move forwards. -1 is backwards at full speed. 1 is forwards at full speed. 0 is it's not moving. So let's say you want to move like forward at half speed, you would make it 0.5. So this is kind of what a basic, really basic motor code looks like. Most of the motor code in our robot is a little more complicated than this. And before I go into that, I'm just going to go over the Spark like basic motor, and we can look at some differences. So as you can see, it is structurally pretty similar. You have to make your motor object, you have to make your config object. There's just little differences in the way that you structure and define things. And so, for example, with the motor, when you're defining a motor, not only do you tell it your device ID, but you also tell it whether or not, like what type of motor it is. Most of the motors we use are brushless, so most of the time you'll be putting brushless like this does. You also, when you're defining like your mode, it's just, the line looks a little different. It's really just differences in syntax between the two libraries because they're both made by different people. But otherwise, it's like the same concept as the other motor. Okay. So now I'm going to go into some more complicated motor code. I'm going to start with, we were doing the talent before, so I'll do voltage control first. Okay, so normally when we have a motor on the robot, it's either doing one of two things. Either we want it to go to a certain position, or we want it to go at a certain speed. Normally we do use set duty cycles sometimes, but a lot of the times we use either voltage control or position control. So I'm going to go over voltage control first. I will say, once again, like, they're pretty similar, voltage and position control. There's very few differences in them. It's just what they're controlling, that's the main difference. So for voltage control and position control, because with set duty cycle, you're just choosing an amount of power. Like, I want you to give it this much power and that's it. With these controls, you want it to go to a specific speed or a specific position. And in order for it to go to that position without overshooting or undershooting, you're going to use something called a PID. So PID stands for Proportional Integral Derivative Controller. You don't need to remember that. I don't know why I do. And basically what it does is it prevents your motor from overshooting or undershooting your target. And the way it does that is that instead of, let me get a marker. Let's say you have a target at here, right? What your motor is going to do is it's just going to try to go up to there, it's going to overshoot, and it's going to keep trying to correct itself. You don't really want that. With a PID, what it'll do instead is it's going to slowly ramp up to that target position and then stabilize itself. So as you can see, there's kind of like a curve there. So instead of shooting up, straight and down and up and down, it'll curve into its target position. And so, does that make sense so far? That's like the concept of what PID is. And so with PID, there's three main things you'll control, and then there's also some other values as well. So the main three are P, I, and D. Your P, normally when you're tuning, will be the first thing that you start tuning. And what your P does is your P is kind of that value that initially like helps you reach your target. So here's some ways that you can correct it. Let's say you're consistently undershooting your target. Then you're probably going to want to start by highering your P, right? But if you're consistently overshooting it, maybe don't touch your P. So your P is kind of what helps you reach that target. And then the next one is your I. So your I you're going to hopefully use less often. You only really use it if you need to use it. But what your I does is your I basically takes where your position is and it like shoots it up to reach your target. Let's say I am here, right? This is my target, but I'm like really undershooting it. Then I would use I, which would like shift this up and make it reach your target. But with I, sometimes you'll overshoot because P like corrects to kind of be at the target. I just pushes it up no matter where it is. So if you're overshooting, don't use I. And then the last one of the main ones are D. Your D, what that does is it prevents oscillation. So even with the PID, you guys know what oscillation is? Okay, so oscillation, what that is it's when you go like this. It's when instead of stabilizing at a position, it kind of keeps trying to correct itself. And so your D basically dampens the motor, and so it tries to prevent oscillation. So instead of being this, it might look a little more like this, with very little oscillation. Okay, any questions? There's also feed-forward values, like here you can see S and B. I'm not really going to get into that right now. So, just to recap this so far, right now this is structured, like just look here up, basically like the other one was. The only difference is I forgot to put like a current limit, which you would normally have to do, and then I put the PID inside of your config object. So basically I just did configs, and then I put the slot, and then KP or key, KI or whatever, and then your value. And the reason you have different slots is because like what you can do if you want to is you can have multiple PIDs on your motor. So you could have a PID for velocity control and a PID for position control on the same motor, but you put them in different slots. So that's why you have to define the slot there. You start with slot 0 normally. Okay, now I'm going to talk a little bit about the actual functions. So, this is what you'd use to actually set the velocity to a certain point. Oh, let me also look up here. So this structure for the velocity control is like specifically for Phoenix motors. This is what we have running right now for our intake spin motor on the sibling robot. That's what it's going to use. But you have to make, for some reason, a velocity request object up here. And then here what you do is you basically do your motor dot set control, and then you put what you want your velocity to be, because for velocity control you're picking a specific velocity instead of giving it a certain amount of power, and then it'll move to that velocity using the PID. So it's going to actually try to correct itself instead of overshooting and undershooting. So whenever you want to do velocity control or position control, you're going to need to use a PID. Okay. And now I'm going to talk about the position control. Position control is basically the same thing. For this one's using SparkMax, so the other software, which is why it looks a little different. But for position control, you would also need to use a PID. The way they define a PID in Spark is different a little bit. I mean, they still have your config object, but you do dot close loop, dot PID, and then you put all your values like that instead of defining like every single value individually and what slot they're on. And to set a position set point, it would basically look like this, where you would give it your value, you say the control type. So if you want it to use position control, the one that the best one for SparkMax that we're actually trying to get working right now is the max motion position control. That one will correct itself with the PID. And then lastly, you'd say what your slot would be for your PID. And then one last thing for these motors, I don't really have it on here, but I'll pull up our other code. But you're going to want to probably log stuff for most of these motors. Do you guys know what logging is? So logging is basically we have these like platforms, these visual platforms called, we have Shuffleboard, Smart Dashboard, and Elastic. We prefer Shuffleboard and Smart Dashboard, but like we're gonna have to use Elastic from now on because First is changing their software. But basically what logging is you're basically taking your data and either you're printing it in text that you can see in files, or you're putting it on these visual platforms that First gives us, and it allows you to basically have a way of seeing, okay, like what velocity is my motor at, or what position is my motor at, and you can use it in order to test certain things, make sure your motor is working properly, and also if something goes wrong, you can kind of use it as a diagnostic. Any questions about that? So this is an example of how we log. I know you guys weren't at Tanzila's workshop, so I'll kind of explain what periodic is. But so if you guys have a general idea of how code is structured, right? The rest of this is like the class name, right? These are all functions is what these are. So these are things that you would call at other points of the code. But periodic is something that First has that's special, where basically whatever you put in periodic is called every 15 milliseconds. So let's say you want to log your position of your motor. you want to make sure it's not just logging once and it keeps updating. And so in order for it to keep updating, you'd put it in the periodic function. And then logging looks something like that. You'd say the platform you want to use, so smart dashboard, put number, and then what you want to name your log, and then the value that you're logging.